We are now looking at the intersection point of the three altitudes of a triangle. And the name that we give that intersection point is the orthocenter. So we have the orthocenter being the intersection point of the altitudes. Now we know an altitude goes from a vertex to the opposite side to it, meeting that opposite side at a 90-degree angle. So in the triangle that I drew for you, I'm showing one of our altitudes right here. It goes through point A and meets side BC at a 90-degree angle. We have another altitude that goes from point C and meets side AB at a 90-degree angle. And the third altitude would go from point B to meet side AC, and it meets at a 90-degree angle. And once again, we have this common intersection point that comes up, and that common intersection point is called the orthocenter. So, in terms of finding where that point of intersection is, that orthocenter, where that orthocenter is, we need to find the intersection point of the altitudes. So once again, we're going to be solving a system, a linear system. That means we're going to need to get the equation of the altitude, and actually two of them. We don't need all three, just two of the three. To get the equation of an altitude, we know it's perpendicular to the side opposite the vertex. So that means, therefore, we need to find the negative reciprocal of one of the slopes. So for example, we could find the slope of side AC and take its negative reciprocal. That would be the slope of the altitude that we are trying to find that goes through point B. And since it goes through a given point, in this case for the green altitude here, it goes through point B, we can just sub that into y equals mx plus b along with that negative reciprocal for our slope of AC. So that's really what this comes down to. So let's actually go ahead and try this. So at this point, put the video on pause, turn the page over and try that example. And I will put a solution on the next slide. So when I did this question to determine the point of the orthocenter, I'm looking at the intersection point of our of our altitudes, which are perpendicular to the opposite sides. So we need the intersection point of the altitudes. So I actually found the equations for all three because I wasn't sure which two you found, and this way you can check your solution, but you really only need two of them. So the altitude from A to BC, so from point A to meet side BC, we know the altitude would have to be perpendicular to side BC. So I found the slope of BC to be 1/2, and then I know that the negative reciprocal of 1/2 is -2. So that will be the slope of my altitude. I also know that my altitude has to go through point A, which is at -12.6. So I put those things into my y equals mx plus b, and I came up with my equation of my altitude right here. Y equals -2x minus 18. When you find the slope, or when you find your next altitude, if you find the altitude from B to to side AC, I found my slope of AC to be -3. The negative reciprocal of that slope would be positive and 1/3, so that will be the slope I use along with the point B, since it's passing through point B and meeting side AC. Put that in, I came up with this equation here. And if you tried to get the altitude from C to side AB, you would find your slope of AB, which is -3/8. The reciprocal of that would be positive 8/3, and the altitude passes through -8, -6. Put that all into y equals mx plus b, and for some reason I actually forgot to write down the actual equation here as a final step. Your y should be positive 8/3 x, and then we have I believe that was a plus 46/3. Okay, it might have been a minus 46/3, but I think I erased that minus and it's a positive 46/3. So you may have found that one and worked with that one. Now when I solved my system, I chose to use my first two equations that I found, the blue and the red one, and I subbed it in, And then because I had fractions, I multiplied every term by 3 to undo the fractions. I came up with an x value of negative 50 over 7, and my y coordinate, once I set that in, was negative 27 over 7, so my orthocenter would be at this particular point here of negative 50 over 7, comma, negative 26 over 7. Go ahead and figure out how to calculate the area of this triangle, knowing, just in case you forgot, knowing that the area of a triangle is base times height divided by 2. And base and height always have to meet at a 90-degree angle. Now, if you think this is connected with orthocenter, it is in terms of altitude. However, if you look at a key piece of information here, this will help you reduce your problem, or reduce the problem, not to say it's your problem specifically, but the problem for math.